please like, share my videos and subscribe my channel if you have not already subscribed. Now, about 14 questions were asked on the topic limits, continuity and differentiability from the section Differential Calculus in the JEE Main January 2024 session. Now, in this video, we discuss the first 4 questions. Now, we go to the first question. This question has appeared in the 27th January 2024 in the first shift. The given question is, consider the function f of x defined like this, that is a times 7x minus 12 minus x square by b times mod of x square minus 7x plus 12 when x less than 3. F of x is equal to 2 power sine of x minus 3 by x minus bracket x when x greater than 3. F of x is equal to b when x is equal to 3, where bracket x denotes the greatest integer less than or equal to x. If s denotes the set of all ordered pairs a comma b such that f of x is continuous at x is equal to 3, then the number of elements in S is, we are given 4 options. So we are given a function f of x and S denotes the set of all ordered pairs a comma b such that f of x is continuous at x is equal to 3, required to find the number of elements present in S, that is n of S. So that's the given problem. S, n bracket S. Agreed. Let's now discuss the solution of the problem in detail. We have the function defined like this. Agreed. Now, we have S is the set of all those a comma b such that f of x is continuous at x is equal to 3. Agreed. Now, f of x is continuous at x is equal to 3 if and only if limit extends to 3 plus of f of x is equal to limit extends to 3 minus of f of x is equal to f of 3. That is, the left limit is equal to the right limit is equal to the limit at x is equal to 3. Right. Now, first we take limit extends to 3 minus of f of x. Extends to 3 minus. That means in this x is tending to 3 from left. So from left, the definition of f of x is this one. So that is why we have written like that. Now, limit extends to 3 minus of, in the numerator, we have taken a minus common, minus a into bracket, in brackets, x square minus 7x plus 12 by b into mod of x square minus 7x plus 12. Look at this mod. Look at this mod. So, let g of x is equal to x square minus 7x plus 12. That is this one. The expression that is inside the modulus. That can be factored as x minus 3 into x minus 4. How these g of x will behave? We see that g of x is positive for all x belongs to the open interval minus infinity to 3 union 4 to infinity. This is a routine discussion. If it is like this, it will be like this. So g of x is negative for all x belongs to 3 to 4, open interval 3 to 4. Now, as x tends to 3 minus, what will be g of x? It is positive. It is positive. Limit x tends to 3 of f, 3 minus, that is of the g of x, that is x square minus 7x plus 12, is positive. Is positive. From the left, if x is tending to 3 in this, g of x is positive. G of x means x square minus 7x plus 12. So the mod of x square minus 7x plus 12 as limit x tends to 3 minus is positive. Therefore, the modulus will go away. And you can write minus 1 out. Limit x tends to 3 minus of a times x square minus 7x plus 12 by b times x square minus 7x plus 12. And cancellation takes place and it is 1. Therefore, you get minus 1 into a by b. A by b minus a by b. Right. So now limit x tends to 3 plus, that is from the right, that is right limit we'll do in the next slide. Right. So that is our fx. That's what we have done so far. Agreed. Now limit x tends to 3 plus, that is the right hand limit of fx, is equal to limit x tends to 3 plus means in this, so 2 to the power of sine of x minus 3 by x minus bracket x. Right. So we will write for x 3 plus h. As h tends to 0, we will consider. So limit h tends to 0, 2 to the power of sine of 3 plus h minus 3 by 3 plus h minus bracket 3 plus h. It's not 3 plus 4, it is 3 plus h. It is 3 plus h. And bracket 3 plus h is 3 because h greater than 0. So bracket of 3 plus h is 3. So you will write 3 here. So 3 plus h minus 3. This 4 is there is a topographical error. It is h. That is here we have written h. So 3 cancels and you will get a limit h tends to 0, 2 to the power of sine h by h, and a limit h tends to 0, sine h by h is 1, that is 2 power 1, that is 2. Agreed. So the right hand limit is 2. And the value of f of x at x is equal to 3 is given to be b. So f of 3 is b. F of 3 is b. Now recall this equation 1. That is, f of x is continuous at x is equal to 3 if the right limit, left limit both exist and they must be equal, and they must be equal to the value of the function f of 3. So if you apply that one, so f of x is continuous at x is equal to 3 if the right limit, left limit at 3 is equal to the value of the function f of 3. So that means minus a by b must be equal to 2 must be equal to b. So they are all equal. So b is equal to 2 and a is equal to minus 2b. And when b is 2, a is minus 2b will be minus 4. So there is only one ordered pair. Only one ordered pair, that is a is minus 4, b is 2. So a comma b is minus 4 comma 2. Only one ordered pair has come where the f of x is continuous at x is equal to 3. So let's get back to S. The set of all those ordered pairs a comma b such that f of x is continuous at x is equal to 3 is the set consisting of only one ordered pair, that is minus 4 comma 2. Therefore n of S, the number of elements present in S, is only 1. So the answer to this question is option 2. So if you see the options, we have the answer n of S is equal to 1 appears against option 2. Therefore, the answer to this question is option 2. Right. Now we go to the next question. The next question is, if a is equal to limit extends to 0 under the square root of 1 plus under the square root of 1 plus x to the power of 4 minus root 2 whole by x to the power of 4. B is equal to limit extends to 0 sin square x by root 2 minus under the square root of 1 plus cos x. Then the value of AB cube is, we are given 4 options. Right. Let's now discuss the solution of this problem in detail. We first consider A. Limit extends to 0 under the square root of 1 plus under the square root of 1 plus x to the power of 4 minus root 2 whole by x to the power of 4. B is limit extends to 0 sin square x by root 2 minus under the square root of 1 plus cos x. Let's first evaluate A. Right. To evaluate A, we will rationalize this one, the numerator. That means we multiply and divide by under the square root of 1 plus under the square root of 1 plus x square x to the power of 4 plus root 2, divide and multiply. So limit extends to 0, this is the function, and this is the rationalizing factor. Now when you multiply these two, which are appearing in red, it is a plus b into a minus b, that is a square minus b square, and that will be equal to limit extends to 0. This is a square minus b square, 1 plus under the square root of 1 plus x to the power of 4 minus 2 by x to the power of 4. And limit extends to 0 of 1 by this one. And limit of the product is equal to product of their limits. The numerator, when multiplied with the numerator here in red, it has become this one. Now, when you take the limit extends to 0 of this one, it is 1 by 2 root 2. 1 by 2 root 2. And this is 1, if you simplify, under the square root of 1 plus x to the power of 4 minus 1 by x to the power of 4. So, this and the limit of this is 1 by 2 root 2. So, you take 1 by 2 root 2, limit extends to 0, again rationalize the numerator. Rationalize the numerator. So, 1 by 2 root 2, limit extends to 0, the function, and this is the rationalizing factor. Under the square root of 1 plus x to the power of 4 plus 1 by under the square root of 1 plus x to the power of 4 plus 1. Now multiply the numerators. Then a square minus b square, a plus b into a minus b, a square minus b square, you will get 1 plus x to the power of 4 minus 1. Minus 1. And limit extends to 0 of 1 by under the square root of 1 plus x to the power of 4 plus 1. So this is right. When you multiply these two, this has come here, and the limit of this one, and limit extends to 0 of this one is 1 plus, so this is 1 plus 1 only, 1 by 1 plus 1, 1 by 2. And here it is minus 1 plus 1 cancels, x to the power of 4 by x to the power of 4. 1 by 2 root 2, limit extends to 0, x to the power of 4 by x to the power of 4 into 1 by 2. So this will be 1 by 4 root 2. Limit extends to 0, x to the power of 4 by x to the power of 4 is 1. So 1 by 4 root 2 you will get. Right. That is the evaluation of A. Let's get into B. Now take the limit extends to 0, sin square x by root 2 minus under the square root of 1 plus cos x. You are rationalizing. This is the rationalizing factor. Multiply and divide, and in the denominator multiply a plus b into a minus b, you will get a 2 minus in brackets 1 plus cos x, and this factor, the numerator will remain same, and limit you have to take. So that is equal to limit extends to 0 sin square x by 2 minus in brackets 1 plus cos x into limit extends to 0 root 2 plus 1 under the square root of 1 plus cos x. Right. Take the limit extends to 0. So root 2 plus this is 1 only, cos 1 plus 1. So cos x, as x tends to 0, cos x tends to 1. So root 2 plus root 2, that is 2 root 2. That is 2 root 2. And sin square x by 2 minus 1, that is 1 minus cos x. 1 minus cos x. So that will be limit x tends to 0. For sin square x, we have written 1 minus cos square x. And the denominator 1 minus cos x, this is 2 root 2. And this will be 2 root 2 times limit x tends to 0, 1 plus cos x into limit x tends to 0, 1 minus cos x by 1 minus cos x. This is 1. And as x tends to 0, this is 1 plus 1, 2. So this is 2 root 2 into 1. That is 4 root 2. So A is 4 root 2, 1 by 4 root 2, B is 4 root 2, and required to find the value of AB cube. That is A is 1 by 4 root 2 multiplied by B cube is 4 root 2 cube, and 4 root 2 cancels. You will have 4 root 2 square, that is 4 square into 2, that is 16 into 2, that is 32. Let's look at our options. Our answer 32 appears against option 2. The answer to this question is option 2. That is the detailed discussion of the solution of the given problem. It is definitely an easy question. We now get into the third problem. And this question has appeared in the 27th January 2024 and in the second shift. And the given question is, if limit x tends to 0 of 3 plus alpha times sin x plus beta times cos x plus log of 1 minus x to the base e whole by 3 tan square x is equal to 1 by 3, then required to find the value of 2 alpha minus beta. We are given 4 options. Right. Let's now discuss the solution of the problem in detail. We are given limit x tends to 0 of 3 plus alpha sin x plus beta cos x plus log of 1 minus x to the base e whole by 3 tan square x is equal to 1 by 3. That means the limit of this exists as a finite number, that is 1 by 3. Agreed. Now we write down the Maclaurin's expansions of sin x, cos x, and log of 1 minus x to the base e. And we multiply and divide by x square and separate the terms. So limit x tends to 0, 3 plus alpha into sin x expansion. We have written x minus x cube by factorial 3 plus so on and so forth. Plus beta times the expansion of cos x, 1 minus x square by 2 factorial plus x to the power of 4 by 4 factorial minus so on and so forth. Plus logarithm, that is minus x, log of 1 minus x, minus x square by 2 minus x cube by 3 plus so on and so forth. Into, we have multiplied and divide by x square. So 3 into x square by tan square x. We have separated like this. Limit of the product is equal to product of their limits. That we do in the next step. And we write it as 3 plus beta, that's the constant term, plus alpha minus 1 times x, that is the coefficient of x. Then the coefficient of x square, we write minus beta by 2 minus 1 by 2 bracket x square plus the higher powers of x, that is x cube, x to the power of 4, so on and so forth. So we write, so limit x tends to 0, 3 plus beta, alpha minus b 1 into x, minus beta by 2 minus 1 by 2 x square, plus minus alpha by 3 factorial minus 1 by 3 x cube plus so on. So 4 by 3x square into limit of the product is equal to product of their limits. Limit x tends to 0, x square by tan square x is equal to 1 by 3. And this is, limit x tends to 0, tan x by x is 1. So this will be 1 only. This will be 1 only. And when you look at this, the higher powers, they are higher than the x square. And x cube by x square. So x will remain in the numerator, and as x tends to 0, they will all become 0. That means all the terms higher than x cube, including x cube, they will become 0. So take the limit. Limit x tends to 0, 3 plus beta alpha minus 1 times x plus minus beta by 2 minus 1 by 2 x square. Those terms have become 0 by 3x square, and the limit of x by tan square x square by tan square x as x tends to 0 is 1. So it is equal to 1 by 3. Agreed? Agreed. Agreed. Now separate. Now limit x tends to 0, 3 plus beta plus alpha minus 1 into x by 3x square plus limit x tends to 0 minus beta by 2 minus 1 by 2x square by 3x square is equal to 1 by 3. And limit exists. That's what it says. Limit exists. And that is equal to 1 by 3, which is finite. Finite. And when the limit exists and it is finite, when this 3 plus beta is 0, alpha minus 1 is equal to 0. Right. So since the limit exists and is finite, we must have 3 plus beta is 0, alpha minus 1 is equal to 0. That is, beta is equal to minus 3, alpha is equal to 1. Why not? Suppose you say, no, they are not equal. If they are not equal, limit x tends to 0, 3 plus beta plus alpha minus 1 into x by 3x square does not exist. It tends to infinity. In other words, it does not exist. The limit does not exist when they are not equal to 0. Therefore, they must be equal to 0 because the limit exists. Because the limit exists. So that's the reason. That's the reason. So, and this part limit exists. That is equal to minus beta by 2 minus 1 by 2 by 3. That's equal to 1 by 3. Yes, this is satisfied when beta is equal to minus 3. Substitute here. So that means the values of alpha and beta are alpha is equal to 1, beta is minus 3. Required to find the value of 2 alpha minus beta, that is 2 into alpha is 1, 2 minus beta is minus 3, minus of minus 3, that is 5. So let's look at our options. Our answer 5 appears against option 4. Therefore, the answer to this question is option 4. That is the detailed discussion of the solution of the problem from the section Limits, Continuity and Differentiability from Differential Calculus. Now let's now move to the next question. Question number 4. The given question has appeared in 27 January 2024 in the second shift. The given question is, consider the function f from the open interval 0 to the set of real numbers defined by f of x is equal to x by 2 plus 2 by x, and the function g of x defined by g of x is equal to the minimum of f of t when 0 less than t less than or equal to x and 0 less than x less than or equal to 1, and g of x is 3 by 2 plus x when 1 less than x less than 2, when g of x is also defined from 0 to 2, open interval 0 to 2. then we are given 4 options. Option 1, G is continuous and differentiable in the open interval 0 to 2. Option 2, G is not continuous in the open interval 0 to 2. Option 3, G is neither continuous nor differentiable at x is equal to 1. Option 4, G is continuous but not differentiable at x is equal to 1. So in an essence, we have to talk about the continuity and the differentiability of this function g of x when g of x is defined like this. Agreed. We will now discuss the solution of the problem in detail. Right. We have the function f defined from open interval 0 to 2 into the set of real numbers defined by f of x is equal to x by 2 plus 2 by x. Agreed. Now looking at g of x, in g of x the minimum of f of t they wanted. The minimum of f of t can be thought of if you know the nature of this function, that is the increasing and decreasing nature of the function. If you know, then the minimum can be found out very easily. So to find the minimum, that means increasing and decreasing nature, we have to take the first derivative. So the first derivative test we apply. F prime x differentiate x by 2 is 1 by 2 plus 2 by x differential is minus 2 by x square. And the f prime x is x square minus 4 by 2x square after taking the LCM. And in the interval 0 to 2, it is negative. You take any convenient point, that is 1. Substitute here, it will get negative. So therefore, this is negative in the open interval 0 to 2. Therefore, f of x is a decreasing function in the open interval 0 to 2. So if it is a decreasing function in 0 to 2, and the minimum can be found out very easily. So now let's see. We have g of x is given to be minimum of f of t when 0 less than t less than or equal to x. So in 0 less than t less than or equal to x, the minimum of f of t is f of x only. This is f of x. But x will vary 0 less than x less than or equal to 1. And this as it is. So now see, note that f of t is minimum at x in this interval 0 to x, closed at xn, semi-open, semi-closed interval. And the minimum will be at this point. Because it is a minimum, it's a decreasing function. So the minimum attains at this point. And since fx is a decreasing function in 0 to 2. So that means the minimum of f of t will be f of x, and x varies 0 less than x less than or equal to 1. So the minimum of f of t is f of x, 0 less than t less than or equal to x, and 0 less than x less than or equal to 1. Therefore, g of x will be f of x, where 0 less than x less than or equal to 1, and g of x is equal to 3 by 2 plus x, when 1 less than x less than 2. We continue in the next slide. So that's what we have. And our question is about the continuity and differentiability of this function g of x. So we first talk about continuity of g of x. And if we look at g of x, f of x is a continuous function. 3 in the interval 0 to 1. 3 by 2 to 1, 3 by 2 plus x is a polynomial. It's continuous in this interval. So it is continuous in the open interval 0 to 2, except possibly at x is equal to 1. Because at x is equal to 1, there is a shift in the definition of the function. So clearly g of 1, because 1 is included in this interval, will be f of 1. So f of x value is x by 2 plus 2 by x. When evaluated at x is equal to 1, it is 5 by 2. And g of 1 plus, that is the right hand limit of the function g of x at x is equal to 1. So in this limit extends to 1 of, in this, 3 by 2 plus x. As x tends to 1, 3 by 2 plus 1, that is 5 by 2. They are equal. G of 1 plus and g of 1 minus is same as g of 1 is 5 by 2. They are all equal. Therefore, g is continuous. G of x is continuous at x is equal to 1. And thereby, g of x is continuous on the whole of the interval 0 to open interval 0 to 2. Let's look at our options. Right. Now, in option 2, g is not continuous for all x in 0 to 2. It is continuous on the whole of the 0 to 2. Therefore, this is not true. This is not true. And in option 3, g is neither continuous, it said. Therefore, this is also not true. So 2 and 3 options have gone. Now 1 and 4 options depend upon the discussion about differentiation. Differentiability of g of x. Now g of x, you take g prime x is equal to f prime x, because fx is a differentiable function in the interval 0 to 1, 0 less than x less than or equal to 1. And the derivative of 3 by 2 plus x is 1 in the interval 1 less than x less than 2. And that is f prime x is x square minus 4 by 2x square when 0 less than x less than or equal to 1. And it is 1 when 1 less than x less than 2. Agreed. And g of x is differentiable everywhere in the open interval 0 to 2 except possibly at x is equal to 1. Because there is a shift in the definition in the g prime. So let us now discuss about differentiability at x is equal to 1. So g prime 1, x is 1 is included here. G prime 1 will be x square minus 4 by 2x square when x is equal to 1. That is 1 minus 4 by 2. That is minus 3 by 2. And g prime of 1 plus in this as x tends to 1 from right g1, that is the value is 1. The g prime of 1 plus is 1. They are not equal. G prime of 1 is same as g prime of 1 minus 3 by 2 is not equal to 1. Therefore, they are not equal. They are not equal. Thus, the differentiability is lost at x is equal to 1 for the function g of x. So, g of x is not differentiable at x is equal to 1. So, g of x is differentiable in the open interval 0 to 2 except at x is equal to 1. So, your option 1, g is continuous and differentiable in the whole of the interval 0 to 2 is not true, because it is not differentiable at x is equal to 1, and x is equal to 1 is a point in the interval, open interval 0 to 2. So, option 1 also has gone. And now, what are the properties? G of x is continuous at x is equal to 1 and g of x is not differentiable at x is equal to 1. So, the option 4 is g is continuous but not differentiable at x is equal to 1 is the correct option. So, that is the option 4 is true. So, that is the detailed discussion. The answer to this question is option 4. And that is the detailed discussion of this problem. Right. It is definitely a good question. Right. I am sure that you have understood the solution of this problem. I am sure that you have understood the solutions of these 4 questions what I have been discussing in this video. I wish you all the best. Thank you.